Okay, year 8, welcome to your video tutorial. Today we are going to have a look at angles in a triangle. In particular, we're going to have a look at interior angles, so angles on the inside of triangles. Okay, the ancient Greek mathematician Euclid discovered that angles in a triangle always add up to 180 degrees. No matter if it's right angled, no matter if it's obtuse or acute, no matter the side lengths, if it's a scalene or isosceles, no matter what triangle it is, all of the interior angles, so all three of them, all add up to 180. We can use this idea to find missing angles in triangles, okay? So the first fun fact that you need to know is angles of a triangle add up to 180. So let's have a look at some examples of when we're asked to apply this. Find the value of BAC in the following triangle. Okay. Now, if I get given an angle like this, where it says angle BAC, okay, what that tells me, okay, it's asking me for only one particular angle. A is going to be the apex, or it's going to be the bit in the middle, and then the other two rays are going to point out to B and point out to C. Okay, and if I'm looking for that one there, that's A in the middle, pointing out to B, pointing out to C, it's going to be this angle in here. Okay, so if I know Euclid tells me that all angles add up to 180, let's see what I already have. So I have 63 and I have 40. So 63 degrees plus 40 degrees equals 103 degrees. If the whole thing adds up to 180, I simply go 180 minus 103 becomes 77 degrees. So angle ABC, and remember, I write it in the way I've been given it, angle AC equals 77 degrees. Remember, think back, what's my structure and how I answer those responses. So that's a first example. Another thing that you might be asked is to use your understanding of different types of triangles in order to solve this. Now, it says find the value of the pronumeral in triangle ABC. So B is in the middle. I've written the word triangle this time. A's on there, A's on there. So we're after H. Okay, we're after finding that angle in there. Now, how am I meant to do this? I've only been given one angle. Well, you might have noticed something about this triangle. It's an isosceles triangle. I know that because these indicators are given here and here. That tells me, because these two sides are equal, that these two angles underneath here will always also be equal. So this here will also be 65 degrees because those two sides are equal. Okay, so if that's 65 and that's 65, okay, 65 degrees plus 65 degrees equals 130. Therefore, H equals 180 minus 130, which equals 50 degrees. Okay, 50 degrees. That's how I can also use Euclid's understanding of interior angles to find pronumerals. Last example, okay, it says find the value of the pronumeral. Oh, that's odd. This time I've been given two missing angles. But I noticed something here again. I noticed that this is an isosceles triangle because I have two sides of equal length and one side that's different. I know that this angle in here, this W, must be also equal to this angle in here. So first off, I'm given the angle at the top. So 180 minus 50 equals 130 degrees. So I know that 130 degrees is what I have left. Now W doesn't equal 130 degrees. 2W equals 130. So this one and this one. So what I need to do is I need to divide 130 by 2, which will give me 65 degrees. So see how I've just done that question both ways? Sometimes I'll be asked to use my knowledge of isosceles triangles to find out two angles. Sometimes it'll be just one. And that's it, guys. That's interior angles of a triangle.